Alright, welcome back to another video on my channel, map_exe. Today we're going to look at some linear inequalities example problems. So for question 1, we need to solve the following inequalities and find the smallest possible integer solution for x that satisfies each inequality. So first, let's jump into part A of this question. So part A says that the inequality of 2x minus 5 over 3 plus 6x, and this is greater than or equal to 4. First, you may notice that we can just raise this 6x into this fraction right here by multiplying the numerator and the denominator by 3. So it will become 18x over 3. Combining those two fractions together, we get this is equal to 20x minus 5 over 3 is greater than or equal to 4. Multiplying by 3 on both sides, 20x minus 5 is greater than or equal to 4. And after this, you can just add 9 on both sides, so 20x this, and then divide 20 on both sides. We get that x must be greater than or equal to 9 over 20. Alright, so we have reached in this point. We need to find the smallest possible integer solution for this. And notice that 9 over 20 is less than 1, which is the next integer, which is in fact the smallest integer that satisfies this equation. So if you're not sure about whether 1 is a solution, you can just plug in back into the inequality. Plugging in 1 here, you get this will be negative 3 over 3 plus just 6, and says if this is true, and in fact it is. So yep. So in this case, we have found that the smallest integer value for x is x equals 1. That's it for the first part. The second part, let's see what we have. 1 over x plus 1 over 2x is less than 1 over 3. Just double checking if yep. Right, so first thing that you might that might come in mind is to combine these two fractions together, and by doing that, let's just write this and then write the common denominator of the common multiple of the denominators, which is just 2x. And then you can just do some stuff right here. So 1 over x multiplying by 2 on the numerator and the denominator will become 2 on the top plus just 1. And keep in mind this is less than 1 over 3. And simplifying this. And at this point, you can just cross multiply. Cross multiply is valid in solving inequalities, so don't get too worried about that. This will be equal to 9 is less than 2x, which means 9 over 2 is less than x, or x is greater than 9 over 2. And the smallest integer solution that satisfies this is x equals 5, because 5 is the next integer, or I would say the next integer after 9 over 2, and it can be seen that 9 over 2 is just 4.5 or 4.5, and therefore the next integer after 4.5 is just 5. So that's how to approach that smallest integer solution for x type of problem. So finally, the last part of this question is x minus 2 over 3 plus 4. and let's see, less than or equal to 5x. And you can just see that you can just raise 4 to this fraction, so it will be just 12 over 3. Combining these two fractions, and then multiplying by 3 on both sides, and then subtracting x on both sides, or if you're preferred, you can just subtract 15 on both sides. Just either way if you want. And then from this you can just get that 10 over 14 is less than or greater than x, or x is greater than or equal to 10 over 14 can be simplified into 5 over 7. And the smallest integer solution for this inequality is just x equals 1 yet again, because the next integer of the 5 over 7 is 1, and that can be easily seen here. Alright, so that's the first question. Let's jump into the second one. Alright, so this is the second question. It says the solution for this inequality, and notice this looks pretty complicated, but you can just divide this into two cases of simpler inequalities, and then you can just solve that from that. So it says the solution for this inequality can be written as this expression: a is less than or equal to x, and it's less than or equal to b, where a and b are real numbers. So first we need to find the value of a plus b, and then next we need to find the greatest integer solution for x, the smallest integer solution for x, and the greatest rational solution for x. And then finally we need to find if x is equal to 5.2 to satisfy this inequality. Alright, so I would say this question is pretty interesting and kind of pretty tricky if you didn't know the trick yet. Alright, so let's just rewrite our inequality down here. So let's check if I rewritten that right. Yep. Alright, so I'll just separate this into two cases. The first case is I'm going to solve the first part of this, and as the second part I'm going to solve the second part of this. Alright, so I'm going to go on for the first case. So 3 is less than or equal to 6 over 7x. You can just multiply by 7 minus x on both sides to get 21 minus 3x on the left hand side is less than or equal to 6. And then subtracting 21 both sides, you get negative 3x is less than or equal to negative 15. And then divide by negative 3 on both sides, whilst flipping this inequality sign, so it becomes a greater than or equal to, and negative 15 divided by negative 3 just 5. But I would just rewrite this as 5 is less than or equal to x, because it will make things easier when we're going to find each values of a and b later. Alright, so the second case, you can just multiply 7 minus x yet again on both sides to get 28 minus 4x on the right hand side. And you can just subtract 28 on both sides to get negative 22 on here. And then divide by negative 4 on both sides while flipping this inequality sign. So x is right here. And then 22, negative 22 of divided by negative 4 is 5 and a half. And I'm going to rewrite this slightly differently, so it will be something like this. Now to combine these two inequalities together, we can just rewrite two inequality signs right here, and then put an x on the middle. So the place for the place for the red place should be filled with 5 to maintain this inequality, and then the place that we need to fill in the green black is 5.5, again to maintain the inequality. So with this we can just quickly conclude that A must be equal to 5 and B must be equal to 5.5, and therefore A plus B would be just 10.5, or 10.5 if you're comfortable with decimals. And then for part B, we need to find the greatest integer solution. So basically the greatest integer solution for this is just basically 5, because well, we know 5 is on here, and this is we have a line under this less than or equal to sign, so that means 5 can be x as well. And then however, if you want to go outside of this bound, you just can't, because it is out of the region of the inequality. The inequality will never hold outside this bound right here. And since we're looking for only integers, the solution for the first part of part B is just 5. And in fact, 5 is the only integer solution for this inequality. And with that, we can just conclude that the smallest integer solution for x is also 5, because well, we only can substitute 5 as an integer solution for x. However, the solution for part 3 of part B will be slightly different. We need to find the greatest rational solution for x, which is just simply 5.5, because 5.5 is a rational number, and since we're looking for the greatest, we may just count from the upper bound of this inequality, and we're lucky because the upper bound of the inequality is a rational number, so we get our answer straight away. Alright, for C, does the solution x equals 5.2 satisfy the inequality? And we need to explain our answer. So keep in mind, we have found our solution, and in this case I'm going to write in decimals right here, because just to make it easier. So all solutions for x are in between 5 and 5.5, including 5 and 5.5. And notice that 5.2, which is our x number, lies just between them. So if you draw a number line, 5.2 just straight lies between 5 and 5.5. And with that, we can just conclude that x equals 5.2 is indeed a solution, because it satisfies our solution inequality. So just write a arrow right here. Alright, so that is it for the second question. Let's jump into the next one. Alright, for the third question, given the breadth of a rectangle is x centimeters, so why not just draw a diagram of a rectangle? So the breadth, which is the smallest side, is x centimeters. However, I'm not going to write x, the centimeters. And the length is 5 centimeters more than its breadth. That means the length is x plus 5 centimeters. And then the perimeter of the rectangle is no more than 50 centimeters. That means we can just say that the maximum possible perimeter of this rectangle is 50 centimeters. So we can just say this is less than or equal to 50. Form an inequality in terms of x and then solve it. So we know the formula for the perimeter of the rectangle. I'll just write this as P is equal to 2 times length plus breadth. And we know our perimeter must be less than or equal to 50. Therefore, we can just write 2 times our length plus breadth is less than or equal to 50. Knowing that our length is x plus 5 and our breadth is just x. So we can just substitute them in. And then you can just do the simplification part right here. Expanding this bracket, subtracting 10 on both sides, and then dividing both sides by 4 to get x must be less than or equal to 10. So this is the solution of our inequality. And find the maximum possible breadth of the rectangle. Well, it's not that hard to see that the maximum possible breadth is just 10. Because, well, 10 is just the greatest possible value of x. Well, we already know that x is the breadth. So simply the maximum possible length of the breadth is 10 centimeters. So max breadth is equal to 10 centimeters. Alright, so that's it for the third question. Let's jump into the fourth and final question. Alright, for the last question, given x and y with requirements below. So x is between negative 2 and 2, including negative 2 and 2. And this is supposed to be a y. So y is between 1 and 4, including 1 and 4. And x and y are both integers. So we need to find the minimum and maximum possible values of each expression. So let's jump into it. So we're going to find the minimum of the expression x plus 2y first. And notice that the minimum value of x plus 2y occurs when x and y are both minimum. So we can just take the lower bounds of each inequality as our corresponding x and y values. So it will be negative 2 plus 2 times 1, which is just 0. Alright, and on the other hand, the maximum of this expression occurs when x and y are both minimum. So we take our upper bound as our corresponding x and y values. So it will be 2 plus 2 times 4, which is 10. Alright, and next we need to find the minimum of x over y. So notice that the minimum of x over y occurs when y is in maximum and x is in minimum. So in this case, we need to choose our lower bound as our x value and our upper bound as our y value. So in this case, it will be negative 2 over 4, which is just negative a half. And sometimes if you don't know the types of the minimum and maximum values of certain expressions, you can just do some trial and error. And in some questions, these requirements of x and, for example, these requirements of these variables are designed to be quote unquote nice, and will be easy to kind of find the pattern or I would say the minimum and maximum of each expression. So yeah, that's all I have to say for that tip. And on the other hand, the maximum of x and y, x over y occurs when x is maximum and y is minimum. Just the other way around, basically. So this will be x maximum is the upper bound of our x, which is 2, and minimum of y is the lower bound. So we have 2 over 1, which is just 2. And finally, this is a very interesting one. So we have minimum of x to the y. Now, in this case, the minimum of x to the y is I would say pretty hard to see for beginners, I guess. However, if you do some trial and error, notice that if I choose x to be -2 and y to be 3, you'll get this will be equal to -2 to the 3, which is just -8. And we can just do possibly the same for the maximum value of this. In this case, the maximum value of x to the y occurs when x and y are both maximum. So we can just choose 2 as our x value and 4 as our y value to get 2 to the 4, which is 16. So when dealing with this type of problems, if you don't really know about the minimum and maximum values of certain expression, it's probably best to do trial and error. So that's it for today's video. So hopefully you guys enjoyed this video. Please subscribe for more videos and I'll see you guys in the next video. Goodbye.